Hey everybody, we're out here at Cisco Live in Amsterdam, and I ran into Duffy, and we've been talking about Isovalent and eBPF and why that's so awesome. Now, give us some more information on why that's so cool.
Yeah. So I'm Duffie Cooley. I'm the field CTO at Isovalent. I spend a lot of my time doing exactly this, explaining everything. And I don't think that any introduction to Isovalent would be remiss without mentioning something like eBPF. Let's talk about eBPF for just a second. I'll give you some context about what it actually is. So if you were to think of the Linux kernel as an event-driven API, right, where I want to open a file, I want to open a socket, I want to, interact with any of the devices that Linux knows about, all of those things. What eBPF allows us to do first is to instrument what happens in that layer, right? So one of the big challenges that has happened in our world of containerization is that there are all these abstractions, things like namespaces and containers and all of those things. And with all of those abstractions, it's become very difficult to understand like the security space around all of these. So this is why container escapes are a thing. This is why Kubernetes security is super challenging. There's all these, good examples. What eBPF allows us to do is actually capitalize on the context that the Linux kernel knows about as it relates to those security problems, as it relates to that context about what's running, what access does it have, what permissions does it have, what can it do, right? So that event-driven API example, right? If I go back to that with eBPF and I say, inside of all of the containers running inside of my Kubernetes environment, I do not want to allow them to write to particular files or sensitive files on the underlying host. I only want to allow them to write to file systems that are contained within the same container namespaces that the process itself exists in. It's very difficult to do that without being able to sit in the Linux kernel and make dynamic decisions about whether whether an API call is allowed or denied directly in the kernel, and that's what eBPF enables us to do. That's the big payoff, right? Now, bringing this a little bit farther forward, let's talk about like how eBPF actually relates to Isovalent, and we'll also talk about how it all ties together with Cilium. So eBPF is a foundational technology for everything that we've built as part of Isovalent. Isovalent has this thing called the Isovalent Enterprise Network or Enterprise Platform, which is comprised of a few components. Cilium, a network security and observability component, which is implemented directly in eBPF, which means that we're using eBPF to actually make decisions about whether to allow or deny traffic all the way down to the socket layer. And Tetragon, which is actually giving us that same capability, but at runtime security layer. So file access, whether the permissions of a process have changed and what do we want to do to respond to that. So like if there is a container escape, the Linux kernel knows about it because it has to still give you that access to whatever you're going to escape into. So given that context, we can actually say, I don't want to allow container escapes. I don't want to allow any of these things, like a really great decision point. So that's Isovalent Enterprise Platform. That's what we had before we were acquired into Cisco. Now, when I look around the floor here at Cisco Live, I see a variety of different efforts that are trying to also leverage eBPF in conjunction with the work that we're doing, right? So we're working with all of these teams to actually really bring eBPF as a technology into all of these other spaces. It's just incredible, right? Like that means that when I look at Splunk, I have all of that context I mentioned in the kernel. How can Splunk better represent contextually what's happening at runtime? How can I combine that with what's happening at the network layer? How can I use these primitives to better secure like AI workloads and things like that, right? All of these things pin around this core technology of eBPF and the experts in it, which is what they acquired when they acquired Isovalent. So that should give you some insight into what we're doing. It's a really great time, and I'm just continually excited that all of this is still just an incredible opportunity here within Cisco and to change the world, not just for ourselves, but for everybody.
And it's really amazing what you shared with me, and from the kernel level all the way to the context and the observability piece, and just how it all really ties together in the whole one Cisco story. Now, if I want to go get some more information and educate myself further, how can I do that?
There's a few different places you could jump in. One place is ebpf.io. That's a website that we manage because we're the contributors and the maintainers of eBPF and the Linux kernel. We maintain ebpf.io as a place to just learn more about that specific technology and what's available, what people are doing with it, and all of that stuff. And you can go to isovalent.com. Isovalent.com has a few different resources available to you, including hands-on labs where you can actually explore Cilium and Tetragon hands-on and instruct and learn and find out exactly what we're able to do in those scenarios. There's also a ton of white papers, a ton of resources. We usually have webinars and events, and maybe in cities near you, where you can come and join us and kind of learn about all of those things.
Thanks so much, Duffie. That's really amazing.
Thank you.